We should say this in the beginning, that this episode is an episode where you really should just keep it on in the background.
It's like, if you like the soothing sound of people talking Ramda, it's great. Good Monday morning. Today we are going to do like the #1 request on the Fun forum. I never, like, there is an episode requests sub forum that I never look at, but we're gonna do that today, finally. And like, by far, like, people want us to do Ramda, so we're gonna do Ramda.
What is Ramda?
Ramda is a functional programming language with, like, it has a ton of functional programming utility function.
Is it a functional programming language? I thought it was like a JavaScript
Did I
library.
say language? I meant library.
Okay.
Yeah, so most people are aware of some of the functional utility functions that are built in JavaScript, like map and reduce and filter. What else?
Something about then and promises?
No, well, those are not really functional utilities.
Okay.
Like, I'm talking like actual helpful functions that do things. Like,
all right.
But there are actually tons more. You can use like composing functions, creating pipelines. Like, there's so many little things that you can do. And Ramda is a library that has all of these. So it's a library that can be very helpful, but it's also a library that can allow you to create like absolutely insanely not understandable code at all, which is colloquially referred to as Ramda Golf.
It sounds promising.
Yeah.
It's sort of like the async await useless episode, where we did it better by using promises instead of the async await syntax.
Let's not talk about that episode. That will derail me a lot. We did not manage to make that's an episode where I completely managed to not make my point with anything. Yeah.
It was fun.
Yeah, you win some, you lose some.
I think this episode is sponsored.
Today's sponsor is Launch Darkly. Launch Darkly. Do you know that feeling when you're releasing a feature and the information that you want is in 5 different places? What if there was a single place where you could get more visibility and more control? Launch Darkly have teamed up with Atlassian so that you can see your feature flags next to your related Jira stories and issues. Read more about how to combine Jira and Launch Darkly at launchdarkly.funfunction.com. That link is also in the episode description. Okay.
Whoa, just one thing.
Yep.
This is a very, very boring design. Something tells me Ramda is not made by designers.
No, not quite. No. It's made by functional programmers.
Yep.
Yeah, actually, there was a tweet the other day that someone that said that how could point-free programming not be called functional programming? That would have been so much more fun. And I just said that, yeah, this is why Haskell programmers cannot have nice things. Like, it's just like it's a community without no sense of humor. So it's a practical functional programming for JavaScript programmers. Let's just have a look at the documentation and you know, let's actually just go.
Let's build something with this. We can just they have some.
Yeah.
Let's just build something.
Yeah. Okay. So let's just.
I guess if we can have a list of things, is that a good use case to do something?
Yeah, exactly. Let's start with that. Like manipulating lists. Ramda examples. Let's just do the basic one first. Like just do map. Like map in the Ramda way. So first of all, we need to pull in Ramda. const r require ramda. Is that how you do it? Oh no, this is how you do it. There we go. Is that? Oh yeah, now we have ramda. And then we go r dot like r dot map, and then we extract like the property of something like name.
Should we just import something, some data?
Yeah, let's start with some data.
So we can just, let me send you a chat.
Oh yeah, that's good. Returns a gamma deviate by the method of Marsalian and Sang. Yeah, thanks. What is that? What is that even? And no, this is just random numbers and shit. This was the worst, David.
Yep. Okay. Something more will come.
Find me some data. All right. So map. I'm gonna name this function map names. So now we have a thing that we're gonna extract the names out of. So I'm gonna like do like let's say dragons. Hang on. And this is gonna be an array. And each item is gonna be like, oh, can I like this is gonna be John, and then we are gonna have like this is gonna be name Fluffykins, and I also want a dragon that is named David. There we go.
This is just, there is a, scroll down, there's a data set with just counties in the US.
Okay.
So you see counties, oh yeah.
Yeah, okay, I have them. So this...
I don't know what topo.json is.
How can I import this? Or can I or should I just fork it?
Good question. Oh no, go use the populations. Use populations instead.
Okay. Oh, that's good. All right. Oh, this is pure array, right? Oh, sweet. I can just copy this. Populations. D3 is not defined. Let's find that. Yeah, if you're being confused about what we're doing here with observable, observable is kind of like JS Fiddle or CodePen, but it's more oriented around data, and
visualization of data.
Yeah, and it's very, very powerful, and both me and David are fans. It seems a little bit magical at first glance. It's really not, and we really like it.
Yeah, so it's a JavaScript notebook if you're familiar with Python notebooks.
Yeah, which
that says anything. Perhaps only data people.
Yeah, I also like to think of it as Excel for JavaScript, like a more powerful Excel that allows you to use JavaScript and allows you to do React-like things and HTML, and it allows you to add sliders and a lot of other things.
Yep.
It also, like, it's very nice that it also allows you to pull in
whatever npm modules
so
and whatever, everything.
So we can just
and also if you look at the populations, you can just you can just fetch data from somewhere. So someone published this CSV somewhere, and then you can just fetch that and use that very simply.
Yeah, it's very nice. So let's have a look at this. So this is what we have here. We have like an object that has an ID and a population. So let's just, okay, I'm gonna remove my stupid example here. So now I can go like, I have this function here that I created while you were gone called map names. I'm gonna just change this to map like X population. And now I can use this to do like map. Oh, I'm gonna call it map population. And now I can do map population. God, I'm tired today. I'm always tired, like when we do these things. It's just like that's just the thing that we how we roll. Populations. There we go. And now I get like an array of these populations.
Yeah.
And
so that looks very much like what you would do in JavaScript.
Well, yeah, like what you would do with like the function that is built into the array object.
Yeah, that's right.
Let's see that. Let's see if we can. So I'm gonna inline this instead and just do R map. And then I'm gonna grab this inline function here. Gonna do like that, and then population there. So I don't know if you noticed it, because like when I could actually use like the map function immediately after reassigning it. So I basically was doing this. See? I'm gonna just create a block so that it's easier to see. Mapper, I don't know, map func. Now we're gonna call it extract populations. There, and just assign a const. And then we go extract population. I'm going to return that. And that gives us like this array.
That's the same thing.
Yeah. So this automatically happened. This is because Ramda, all Ramda functions does this. Like they auto-curry themselves. And that allows us to reuse them in pretty nice ways. We're going to be talking about more along the lines, like where that is useful. But perhaps we should do that immediately.
Yeah. So so for me that hasn't seen Ramda before.
Yeah.
It's still like, okay, you used map.
Yeah.
Which I already had on population.
Yeah.
So what more can I do here? Like, is the thing with Ramda that you can like do this on everything?
Yeah. Let's have a look actually at. Before we continue, like, just let me show you like the kind of utility functions that you can sort of expect from Ramda.
Yeah.
Let's have a look at, let me pick. No, it's pluck that I'm looking at. Returns a new desk by plucking the same name property of all objects in the list supplied. So this does this pluck method here, or pluck function. This will do exactly what we already did. Let's have a look at extract population. So I can just comment this out and do r.pluck population. And there we go. And then we get exactly the same result.
Yeah.
There's also like this. There's also a function that does exactly what this does, for example. So I could do. I'm gonna save that comment there. I'm gonna comment that out. Put that there, and then I'm gonna do. Oops. r.map. And then instead of doing this function, I could use r.prop, like population. And that gives us the same result. So these are not like the super best examples because they don't save like a lot of code. I think they perhaps make the intent a little bit clearer, as long as you know Ramda, that is. But like in some cases, this can save you quite a bit of writing new functions. So even if the thing that you're writing is rather simple, such as extracting like this little pluck thing, it's still nice to not write everything, write even simple things from scratch, because as long as you're creating just some code, that means that the more things you have that can go wrong, the more things will go wrong. So if you have the ability to use an existing functions, that is often a good idea. Maybe. Then again, it might also be like very nice to just see like something familiar. So that is why ramda is sometimes good to use and sometimes not. But the reason why I use this rmap and prop here is not to give like a super good example of what where ramda is useful. It's to give you an idea about what ramda is and like allow you to use familiar concepts to reason about it.
But what would I use it for? Like when would I feel like, I better use ramda? Like what kind of things do I get stuck with to feel that ramda is perhaps the choice to solve this problem? Or is it more like a concept that if you're invested sort of in the ramda world, you sort of start building everything in ramda?
Yeah.
Or is
kind of sort of like that, I would say. It's
so sort of like if you're used to writing promise, change, then, instead of doing the async await sequential asynchronous writing, or is that the thing? Is that like that comparison?
Let's actually talk about promise chains a little bit, because promise chains are per definition functional, right? And you go like then like. All right. Hang on, I'm gonna fetch a bulle.
Yep, I'm gonna go fetch some water. We were supposed to talk about stickers.
Oh yeah. Here's the deal. If you didn't catch it last week, I announced the fun function sticker pack. There's a lot of stickers, like how semicolons cannot save you, if JavaScript doesn't make sense. There's a coffee break sticker. There's a hello, I'm a rocket surgeon sticker. There's a Fluffykin sticker, also featured all briefly in this earlier in this episode. There is a pressed enter really hard and it worked. And
I heard oppressed, an oppressed enter key. That will be for the next batch.
Oppressed enter key. And then there is a typing is hard sticker. There is a circle CI sticker. And there's also a, God, this is exhausting. There's a murder robot dog sticker that I really like. And there is also, of course, a good Monday morning sticker.
And there's a pusher sticker.
It is. Like, this is a pusher sticker. Like, oh, my. Come on, focus. Focus. Yeah, fun, real time. It's our sponsor, Pusher. This is a software as a service product for doing real time features to your app and stuff like that. And of course, there's a fun function logo sticker.
How can I get hold of these amazing stickers?
Yeah, they will be sent at the end of this month to everyone who is a super patron. So you need to become a super patron before the end of this month. You can find a link to how to become a super patron at in the episode description. What?
So
no, hang on, I haven't eaten my bulle yet, you bastard.
No, but I'm reflecting.
Oh yeah, okay.
I'm reflecting.
Okay.
So I've been watching the small code snippet and trying to figure out, like, so why wouldn't I use map in this example?
Yeah.
And I don't know anything about R still.
Yeah.
But it seems that the whole purpose of it is sort of like a convenience library, sort of like underscore or Lodash.
Correct.
Is that right?
Actually, it's exactly like underscore and Lodash, actually.
So I thought Ramda was sort of like, I don't know, instead of like a streams library, pipeline library or something like that. So I didn't know what it was really, but if I think of it sort of like what I'm used to with underscore and Lodash, which is basically just a utility library.
Yeah.
I see that I don't understand it yet, but I suspect that it's pretty clever and generic, that instead of just having the .map that is attached to all arrays in JavaScript, you can do the ramda map on pretty much anything, because you just tie whatever function to it.
Yeah.
Like it's sort of more general.
Yeah.
That's what I thought while you were fetching the bulle.
Yeah, I guess, and it's a lot more composable also, I would say. I think that which had actually, in order to, like, why wouldn't I just use the filter and map and stuff? I think that we should use something that isn't available on the array object. And we're gonna combine it with map and filter and chain it. So let's have a look. I'm just gonna remove all these stickers from my face. It's also pretty funny that you didn't see, like, because Hangouts is a piece of shite, you didn't see any of
I
that.
have no idea what you did. I sort of suspected what you did.
Yeah. Let's look at Ramda documentation and see if we can find any interesting thing here.
What is take last while?
Returns a new list containing the last n elements of a given list, passing each value to the supplied predicate function and terminating when the predicate function returns false.
Okay, so it's basically walking through a list, and then once we hit whatever condition, we return the rest.
Yeah. It can actually walk through a functor.
Remind me again what functor is.
It's the general version of an array. So a functor is something that you can map.
Yeah.
As you see here in the example, you can also do it on a string.
Yeah.
So it takes last while it's not. So this here, it takes last while it is not R, and it takes the string ramda, and then that becomes amda. So this is one of the nice things about Ramda is that you can it operates on not just arrays but anything that is a functor.
And to do that in ordinary JavaScript, you would first you would take the Ramda string and then split it to turn it into an array, and then filter it, I guess.
Yeah, actually, let's
or you would map it and then. Yeah, how would we do that?
Yeah, actually, let's just do that. We're just playing around here. So we have this thing here, amda. Let's try to re-implement this in vanilla JavaScript. How would you do that? Can I pin this? Yeah. So we have this thing, const. Hang on.
Yeah, so you would start with the array. Okay, yep.
The string.
Oh yeah, the string.
Yeah, so.
And then you would split that with an empty string.
Yeah, exactly. We have to make it into an array first. So it's like string split.
Yeah. No.
No. Oh yeah. Yeah. Exactly.
No.
Yes. Like that. Yeah.
Yeah.
And then we have turn. Yeah. Okay. So now we have this as an array. And then we're gonna take the last one while we. Okay. So. I guess.
So would we?
We'll have to reverse it first, right? No,
or we could just map. We could do it either way. We could just but we couldn't do map because if the string was, we want to, because the first occurrence of whatever of the R should just terminate. So my initial hunch was okay, we do array.map.
Yeah.
And then just return everything but capital R.
Oh, and then remove.
But what would happen if we had ramdar? then we would get amdar. So that doesn't work. Because then we'd have to loop through it. We would have to terminate mid-map.
Oh, yeah.
I guess.
Mm.
We could... I don't know how that would work. Or we would have to have like a memory somewhere. We could perhaps... I don't even know. We could perhaps reduce it to a new array that would just concatenate until we reach some...
Well, I mean, couldn't we just like, okay, let's see. I'm just gonna take the, if we just reverse it, what happens? Amda, and then we just keep taking, like, we're just gonna call it this to like const collected. Create a new array, and we just take r dot for each. It's like some kind of weird bastard difference, Frankenstein's monster between functional programming and procedural, but r for each item or character, I guess. We need to declare the predicate here as well. Is it even called the predicate? The callback? This one.
I don't know what it's called. Predicate, perhaps?
Predicate or callback. Let's call it callback. Just for... yeah. So if the for each if the callback yes. Oh, I'm dumb.
What are you doing now?
Now, if callback char,
yeah,
then we add it to the collected push. Push, and then we push the item or the char. And then we return the collected. Does that work? Yeah, but then we...
Yes, but what happens if you tie... What happens if the string is... Does it work with ramdar?
Yep.
Let's just proof that. So you add a capital R at the end.
Ramdar, like that?
With a capital R.
Yeah, it does. It works.
Yeah.
So this is like a re-implementation of it. So it's not like... Can I... This is how we would do it sort of without it, I think. We could... Well, let's try it using reduce. So array reduce.
So we start with an M. I don't know.
Yeah.
Oh, you're right. At the last.
Yeah, exactly. We start with an empty array. I just keep remember like it's prev cur, something like that.
Yeah, something like that.
And then so cur is gonna be the current is gonna be char.
Yeah.
And then if callback char, then we return then we return prev, but we concatenate on the char. Else, then we just return prev, I think. So work return.
Yeah, that's right.
Wow, did that work? Did I just write like a reduce correctly from the beginning? I'm skeptical.
I think that works.
Yeah, actually I did. That's weird. Yeah, I did. Yeah, exactly. It's not quite right though. because it's in the wrong. It's adma. It's supposed to be amda because we like this last
you
part
reversed
is
it
not
before.
Yeah, so we could cheat I guess we could write it in the reduce if it somehow figures out that it's last index, or we could just reverse it at the end.
Yeah, let's just reverse it.
So yeah, so now we have this out. Then we get rid of like this statefulness, proceduralness here.
Yeah.
So now we have sort of implemented this, I think.
Yeah.
We can actually just write this as a function now. So we can do function take. Let's do this. Const take last while. And then we're gonna call it like callback and the array, I suppose. No, it's the string. No, yeah, let's call it array because this accepts array right now. I'm gonna just indent this nicely. There we go. And now we can do like return take last while and paste in this callback and then do the
string.
Yeah, exactly. So it's string split reverse.
Oh, yeah.
There we go. Yeah, amda, it works. We actually need to join it as well.
Oh yeah.
So join. Whoops, but not with commas.
Just empty string. Yeah.
So there, amda, and let's actually take last while string. And let's have the string here and then string, and then do this. Then do this processing here first. Take last while string. All right, so now we have re-implemented what Ramda does. So it's like not a ton of code. Especially like we could like make this into a one-liner, I think, with an arrow function. Yeah. And like this is very recurring in Ramda. It's kind of like it saves you like 10 lines of code here, 10 lines of code there. But over time, it tends to like add up a lot. Mm-hmm. So like normally it's not the map and the prop and the things that save you a lot of time. It's like stuff like this. Yeah. It's just pretty handy, and it's also nice that you can just throw in a string in it and you can throw in an array in it, because this thing here, this doesn't have like we can't throw. This is not as generic as take last while.
So are you saying that we could? What would happen if we in the R take last while would input an array instead of the string? Would that work? Is it that generic?
Yeah, this one. Yeah, it can handle both strings and arrays. I'm not sure what else it can handle, honestly. Like, if it handle iterators? I'm not sure. I don't know. Hypothetically, I think that Ramda or a library like Ramda could be used to implement handle iterators, so that it could go through like streams or anything, or like node lists in the
when you query the DOM.
Yeah, exactly. Stuff like that, or the arguments object in functions and stuff like that, all the whatever now.
Okay, so for me now, Ramda seems like a convenience library. Great. Okay, it had R take last while, which we just happened to pick randomly.
Yeah.
But what would happen, like, when would I feel that, like, okay, this was handy, but I don't still see the big power of Ramda?
Yeah.
Like, to me, this just looks like an underscore or Lodash alternative, but I don't see what makes it more than those.
Yeah. Okay. So let's try to attack that a little bit. And for me, composability is one of the more interesting things with it. Let's see if we can figure something out.
Yeah. Explain what you mean by composability.
Yeah. So let's say we have this populations array here, and so we do populations, and then we go like filter if it has a population above
50,000.
Yeah. Okay.
Return.
Yeah. Cool.
Okay.
So
Now we got 1,000 instead of 3,000.
Yeah.
200.
And let's then we're gonna do like a I'm kind of like thinking that I want to get like take last while in here. It's kind of like a stupid example, but let's imagine that it was useful.
But change edit populations. Go to populations.
Yeah.
And just output the state and count in, and because they are strings, and perhaps we could just say that as soon as we reach one state.
Oh yeah. So how do we do that?
Then just comma state colon row.state in the map there.
Oh. State. Oh, okay. I getcha. Yeah, so now we have state here, and
I had hoped that it would be a nicer state.
Yeah, but that's fine. That's not fine. Yeah. So the state is going to be string 02. So let's say that we want to just keep running until we hit until we hit a certain state. We could do that with filter, I suppose, but suppose that the condition was something else. Yeah. Then, like, if this was a promise chain, we could have done then. Right? But there's no way of processing in a chain here. You get me?
No, you just get a new array.
Yeah, exactly. So in order to do that, I would have to do like const filtered populations, and then I would have to do like the run the take last while on it. On like in the filtered populations, which is, I mean, it's not horrible. Let's actually do this.
Yeah, let's break that out into its own thing.
I'm just gonna like actually execute it. And it's state equals 02. And we need to actually have this take last while string. Oh, hang on. We're gonna do r take last while. And t is not a function.
Where is t?
That confuses me. Why does... What?
What? Take last while. No, you had it the wrong way. You should you have the callback first.
Oh
and
yeah, right. Because in functional programming languages, this is always like the filter is always a function, or the callback is always a first function. Okay, that didn't work. Set take last while. I did not state. Oh wait, we need to go back to the last one. How many are there?
1,000.
Okay. Okay,
What do you mean by going back to the last one?
Yeah, let me quickly reverse it. This is why observable is so nice. Populations dot reverse, and it's 56. I'm gonna do that.
Oh yeah.
No, didn't work.
No.
I thought that this would work. Oh yeah, because no. Why doesn't this work? Take last.
Perhaps there are no in populations. It doesn't have anything last to take because there is no state. 56 is not in the list after you filtered it.
But it is in the list. Like I tried to remove the filter here.
Oh, okay. Sorry.
Populations. But yeah, that was exactly what I thought as well. Fine.
Is it the triple equals? Nothing about that, no?
That should be... Let's have a look at how does populations take last one. Oh, while not 56 perhaps? Oh, okay. Then I get 3,000. Okay, weird. Then it starts with 55.
Okay, someone in the comment can explain this. This is what we expected.
It's not all that important, really.
Yeah, this was what we expected.
Yeah, it's not quite what I expected. The important thing is like we have a function that does some kind of processing here.
Yes.
Okay, where am I?
Is it the same? Is it the same length? No.
But now it's 982. Yeah, but now it's on the filtered populations.
Oh yeah. I'm just saying. Okay, I'm just saying that. Wasn't it 982 before you take last while?
Oh, let's see. Oops. No.
No. Oh yeah. It removed 2.
Yeah.
Okay.
It removes some. So it does
yeah,
something.
I just wanted to make sure.
Not a lot. Yeah, but either way, so let's have a look at what you can do with Ramda. Like Ramda has like functions that allows you to combine these things. So we can create like a function that is called, let's say, filter and take last while. And we're gonna do Ramda. I think it's like pipe, perhaps. I think it's called pipe. And then you take like R filter, something like this. Just do that there. And I'm gonna comment this out so that we...
You could do a new code block, but...
Oh yeah, that's actually a better idea. Like now I'm committed to this.
Now it's too late. Too late.
Too late. Too late. It's too late to apologize. Too late. And then I will go like, then I can do R take last while. I'm just gonna
take list
yeah,
while.
yeah, I'm just gonna take this one here. Like, remember here is where the currying that we talked about, auto currying comes in.
Oh, so you don't have to. It just figures.
Yeah, because this
out.
Because this, if I call our take last while without the actual value, it will be a curried version of it. So it becomes this function that is ready to get a value.
Oh, And then in the end of the pipe, you will add the input.
Exactly. So let's do this, populations. So like we do that. Oh, return. Is that it? Yeah, then we get it.
What I like with this, sort of, is that it looks, even though it looks strange, I'm not used to the syntax and everything, but it's sort of like, it's very clean in a way that you understand what goes through the pipe.
Exactly. So
what will happen at each step.
Yeah. So it becomes pretty, like, once you, like, and you're not super familiar with Ramda, but you kind of get it. Like, it becomes like this, the code becomes very like these pipey things where like we process data and everything is like these little atoms. And it forces you to think in terms of small composable functions. So it becomes pretty like, okay, so this is now like its own little thing. So perhaps we want to actually name this. So what was it? Like we could call this like filter.
Large populations.
Yeah, exactly. Is large population. Then you go there. Oh, and now actually this this makes a little bit large so you can perhaps call this large populations except what is state 56, by the way?
I don't know.
Only const only lasts, not last state, without last state.
Because I thought they only had like 50 states, but
yeah, that's a good point actually.
I'm pretty sure they have territories and like America is everywhere. So perhaps it's a state in this list. I don't know. I have no idea.
Yeah, I know.
And perhaps it's just an ID. It's not an iterator. It's just...
Yeah, like this is like literally the worst example. It's so confusing, but I hope that
we're using data that we don't know what the data is.
Yeah.
We don't know what to do with it. We have no clue. We just want to try out Ramda.
Yeah, exactly. Like unprepared and try to just attack it from. So okay. So now we have like these like. Do you see now how large populations without last state, or we can just call this big states or something.
Yeah. And so, okay, this is pretty evident why this is super clear. Like, I love how you write. You have the big states thingy, and then you return big states from you enter the populations, then you get only the big states out without the last state.
Yeah.
Couldn't you do this if we go back to our initial thing? Like, couldn't you do the same thing with like naming functions that you would rename the, like you had filtered populations instead of populations.filter, and then couldn't we have just renamed our take last while and then just chain them sort of?
So you mean like this?
Like I meant with the way we did before we did it,
let me
like
comment
pure
this.
random
Yeah,
stuff.
okay. So let's comment this one out, and once.
Can we do this in a new code?
Yeah, you can do that.
So we can compare them.
Okay, so let me break out. Let's pin that. I'm gonna take these and break them out as, because you're talking about when we have these two, right?
Yeah.
So I'm gonna do that. Is large population. Then I'm gonna do that one. Without last state. I'm gonna get rid of those. And we want to basically rewrite this in like a procedural form, or like without Ramda thing.
Yes.
So let's see. We have populations. No, we're gonna do first function big states, and it takes this array and it checks does like takes array and then it does a filter on it, right? Right, what is it? I don't know. How
is large population.
How does it look? Okay, is large population is well, this cheats a little bit because we partially use Ramda here. So we need to have a, let's say that we call is population.
Is large population, not Ramda.
Yeah, no,
that's a good name.
Yeah, kind of. This is a bit false. Like this is actually the is large population, sort of. This is like filtered version of is large population. So let's call we're gonna rename this and call it filter like only large filter large populations. I'm gonna use that there. And we're gonna extract this is typical when you do like Ramda programming, is that you figure out, hey, I can break this into even smaller named functions. So I'm gonna call this is large population. And we're gonna use that there. Okay. Why didn't this work? Why is this an unexpected token? Oh yeah, right.
No, you're not done.
So now we're gonna do r.filter is large population. Return there, and I'm gonna create a new one that actually used big states. Populations. Okay, so what were we doing? Okay, then we're gonna use like without last state. And we had written, did we keep this one? We're gonna export our take last while string here. No, no, hang on, what are we doing? Oh yeah, let's export this. Then we're gonna do this. So now we have yeah, oh yeah, yeah, okay, that's true. We need to, what do we call it? Take last while string. There we go. And there we have it. Our own implementation of that. We're going back to our big states implementation. Yeah. Now we have like this, because we can't just tack this on, because this is object-oriented, functional sort of kind of thing in JavaScript. It's functional and it's object-oriented. So this actually shows one of the annoying things with object orientation, that it ties like the types very firmly to the thing.
So you would have to wrap the array filter with take last while string?
Exactly.
Is that how we would
Precisely.
do it?
We would have to do this.
Yes.
So you like string.split is not a function. Why does this not work?
Perhaps it's an array instead of a split.
Yeah, exactly. Like now, yeah, exactly. Because now we have another function. Like our take last while does only deal with strings.
Yeah.
So we would have to rewrite our text last while because it's not generic. Okay, let's not do that, but just assume that we had it and it like so. We're gonna
so the whole that we have to wrap it and just I just like if we just compare the two, how you wrote big states using Ramda, and then how you wrote it here.
Well,
it's just looks.
Hang on. I'm trying to make this work. X.
And is it the other way around in this time? No, okay.
Hang on. Let's look at without last state. Yeah, let's just use without last state. So it's like without last state. There we go. Something like that. Yeah, then it works.
Yes.
So you have to like keep wrapping them up like this. While Ramda allows you to do like, it has like these meta compositioning functions that allows you to create like these, it allows you to build functions together into bigger functions.
I like it. I honestly thought that I would just end up with not liking this, and I had prepared a rant how this was just another library that you don't need. But I like it.
Yeah. So just to,
I can't rant.
Yeah. So let me give you like what there is this what Ramda function should I use? This is this little page on the Ramda wiki, which is really nice. Where you can do like, okay, remove values from the start, add a value to the end, combine two lists into a list of pairs based on custom logic.
And okay, so what I like with this is that basically everything that you see there is composable, that you can combine them together in like doing things.
Exactly.
Is that right?
Exactly.
I get it.
So that is Ramda. I didn't prepare like a cell here or anything. I just did everything impromptu, and like I didn't know what questions you were supposed to ask. But I hope that your skepticism reflects the skepticism of the viewer.
Yeah, and if you are either an ordinary forum patron or a super patron, you can go into the forum, because I'm pretty sure that there has been several threads on this, and I'm on Ramda. I'm going to reread them now when I finally understand Ramda. So the whole async await useless thread, didn't that have a lot of examples using Ramda?
Yes, it does. It does.
And I never really understood what they did. And I didn't take the time to learn.
No,
Ramda.
exactly. Like, because Ramda it's very possible to write extremely unapproachable code with Ramda, and functional programming in general, I think. It just has that nasty problem that it can create really inaccessible code. But it can also, if you just constrain yourself a little bit and try to actually make it into readable code and like write your function names very clearly so that they have simple names, and use that, then it can turn into quite nice like flows of stuff.
I like it.
Yeah,
I like it.
Yeah, so perhaps like we should we can do like more Ramda explorations in the future, like look at specific Ramda functions, or like look at composability. I think that this is just the first episode where we just like play around with it.
Yeah, and if you're viewing this and you have like the greatest use case for Ramda, please write that in the comments, because I'm sort of convinced a bit that it's cleaner, clearer, composable. But I would like to see more of these like comparison examples where you can see like the non-Ramda way and then how Ramda makes it better. And I'm sure there are also ways when you make it worse with Ramda, because of course you can do anyway.
Yeah, I think that we should explore that a lot. Like when does Ramda become too much? And like now we like went way far down the rabbit hole, and this is just unintelligible garble that would be simpler to write in plain JavaScript.
When did people start using Ramda? Or is it still like early days, so I can feel like an early adopter if I start using it?
No, I don't think you can use like this. Ramda is very mature. We used it a lot in production at Spotify. Then again, they still call them a 0 version.
But there is a 25 there, I see that.
Yeah, exactly.
It's like, I guess that's like the that you're afraid of going public. Like you're always in stealth mode, because as soon as you go public and try to start charging people for things, or trying to like really, really, really convince people to use it, then it's more difficult. Now it's still a hobby project.
Yeah, you know that's actually the slogan of Haskell: avoid success at all costs. Did you know that?
Okay.
Yeah, so the fact that Haskell is like not widespread and super promoted for mainstream use is sort of intentional from the community, because when it is, like, they can't evolve as fast.
So should we wrap this up with a mention of the sponsor?
Yes. Launch Darkly is a fantastic little software as a service product that allows you to do feature flag management. So if you want to start using feature flag in your application and you don't want to start building that system yourself, which is way more complicated than one thinks. We had an entire team doing it at Spotify for years, I think. Yeah, it's a very nice system. And they are currently promoting this integration with Jira. So you can see, like, connected to your issues in Jira, you can see what feature flags are connected to that issue, and you can see if it is rolled out or not. So it's like very nice integration. If you use Jira or Launch Darkly or thinking about feature flags, that kind of stuff, you should really check it out at launchdarkly.funfunfunction.com.
And remember to become a super patron if you want cool stickers. If you're one of the two people that ended up all the way back here, write in the comments. Just to mention that you watched the entire episode, because this was long and not very efficient, and I don't think you will edit it. It will be very long, even.
This will be a very long episode. Like, if you fought through the episode to the end, like, you're a warrior.
We should say this in the beginning, that this episode is an episode where you really should just keep it on in the background.
It's like, if you like the soothing sound of people talking Ramda, it's great. Like, it just...
You should do like a takeover. You have, like in companies, you often have like this company dashboard with the metrics, how you're performing with all the KPIs. Just hack that thing and just put this on repeat.
Like, perhaps...
Because no one watches those anyways.
Perhaps we should just like screw the teaching part of this channel and instead just do like developer ASMR. It's just like us, like, Ramda.
Yeah, you have a great microphone for that.
That is true, like, Ramda. This is so stupid.
Oh, yeah, and then we can approach sponsors. Like, do you want to be... And we can put like... We can say like Visual Studio Code backwards.
Yeah.
And stuff. Like,
Yeah. If you want the stickers, make sure that you do it before the end of October. After that, we're not gonna print them again. It's gonna be... They're gone. That's the last of them.
And if you're watching this after October 31st, 2018, you can still become a super patron and then harvest other rewards eventually, but we don't know when.
Yeah, other hypothetical rewards.
Then we would just be grateful.
Yeah. All right, that's a lot of ranting. This is a ranty, relaxed episode, but I had a lot of fun.
Thanks for teaching me Ramda, Matthias.
Thank you for allowing me to rant about Ramda, David. You, dear viewer, if you're new, you have just watched an episode of Fun Function. We release these every Monday morning, 0800 GMT. If you are forgetful, you can subscribe by clicking here, or you can watch another episode right now by clicking here. I am MPJ.
And I'm David.
Until next Monday morning, stay curious.